Today's lesson is finding equations involving parallel and perpendicular lines. So it really ties together all the stuff that we've been doing this chapter. So if you're having a little bit of trouble with any of this stuff, this serves as a very good review lesson of everything that's been happening so far in this chapter. So it says, for each of the following line, determine the equation of the line that meets the following criteria. It says parallel to the line, negative 7 halves x plus 9 with y-intercept 21. So I'm going to follow that procedure that we've sort of been talking about, first I write down y equals mx plus b. And then I sort of think if they've given me any of these things. And by given, I don't necessarily mean they just stated what they are, but I can figure them out. For instance, it says parallel to this line. And what we found out about parallel lines was parallel lines will have the identical slope. This line has slope negative 7 half. We want to be parallel to that, so we want the exact same slope. So because it's parallel, we know that the slope has to be negative 7 halves x. So that's what's different in today's lesson is instead of it being given, you just have to do a little bit of thinking about parallel and perpendicular lines to come up with that slope. Now, in this particular question, they kept life pretty easy because they actually said what the y-intercept was as well. So the only thing I had to do in this question was think about what parallel means, and that means same slope. Okay? So we'll just all the rest of these questions, all they do is just up the difficulty level a little bit each time. So next one, perpendicular this time. Okay, so write down y equals mx plus b and think about what they've given me. They said perpendicular to 4/3. So that slope was perpendicular to 3/4. They said the slope was 3/4, but I want to be perpendicular to that. And one of the things we learned this chapter was if we want the perpendicular slope, the slope I want then is the negative reciprocal. What does that mean? I got to flip the fraction and change it to the other sign. If it's positive, it becomes negative. If it's negative, it becomes positive. Well, that didn't take me long. Now I know the slope that I want is negative 4/3. And again, in this question, they made my life pretty easy. They told me what this y-intercept was, so I just write that in there with a negative 13. Next, parallel to this line. Okay, so y equals mx plus b, and I want to be parallel to this one, so I need the same slope as that one. So I need a negative 8 as a slope. And then it says same y-intercept as this one. Oh, the y-intercept of this one is negative 7. So now I wanted parallel to the first line, so I wanted my slope of negative 8. Same y-intercept as the second line, which was the negative 7. Not too bad. You know, that one, I don't think that was a huge jump in difficulty level. You just have to know where to find the information. Again, the number with the x will be the slope. The number by itself is the y-intercept. So this is where they start to ramp up a little bit. This one says perpendicular to the line negative 6x plus y minus 5 equals 0 with the same y-intercept as this line, 5x minus 2y equals 6. And I say this question isn't really ready to be done. Why these questions were reasonably easy is all the equations were in y equals mx plus b form. You see, it's y equals something x plus something. Right there, I could just easily read off what the slope and the y-intercept were. These equations are not in y equals mx plus b form. So I'm telling you the very first thing to do, and I'm going to put a big star here, the very first thing to do when you get equations that aren't in y equals mx plus b form is to put them in y equals mx plus b form. That form gives you the most possible information. So for instance, this one, I'm going to move the 6x or the negative 6 over and make it positive 6x. Move the negative 5 over and make it positive 5. And there's my equation in y equals mx plus b form, a much more useful form. And this one, move the negative 5x, or the 5x over, it becomes negative 5. Divide everything by negative 2, and I get y equals 5 halves x minus 3. I've moved everything, and I've solved for y in terms of x, and so now I've got that in y equals mx plus b form. Now I'm in much better shape to answer the question. Write down my equation, y equals mx plus b. Think about what I want. I want perpendicular to this line. So if that slope was 6, I want negative 1 over 6. I got to flip it from 6 over 1 to 1 over 6 and change it from positive to negative. So I get negative 1/6 x. And the same y-intercept as this, I want this y-intercept here, which is negative 3. See, when it was in y equals mx plus b form, finding the information I wanted was pretty straightforward. So again, so important get these into y equals mx plus b form, you'll find it much easier to do the questions once you've done that. This one is very nice because it ties together many of the lessons of this chapter. Let me go through the procedure from 2 days ago. 1, write down y equals mx plus b. 2, fill in what we know. And what we know this time is that the slope has to be 5/6. It has to be parallel to this line, so I need the same slope as that line. So let me just fill that in, 5/6x. But it doesn't give me the y-intercept. So I'm stuck in this situation. And what we found out 2 days ago is an extra point like this is very, very convenient. That's an x and a y value that have to go together. So what I can say here is when x equals 12, y equals 4, sub that in there. Hopefully you've got lots of experience at this. That was a very important set of homework because it was going to be used all the way through this chapter. And so what I get is, oh, put that over 1, 60 over 6 plus b. That becomes a 10. And then move that over. And I get a b value of -6. So now I've got my equation. Y equals -5/6x, not negative, minus 6. Okay, so that one's a lot like previous days' questions. It could take stuff out of the parallel and perpendicular lesson, and then take stuff out of the finding equations of lines lesson. So all tied into one. 4 more to go. Okay, it's perpendicular to this line and going through this point. So here come the steps. Write down y equals mx plus b. Sub in what I know, and what I know is that the slope has to be -1/4. How do I know that? Well, if it's the slope of that line is 4, I want to be perpendicular to that line, so I've got to find the negative reciprocal. So instead of 4, I get 1/4, and I've got to change it from positive to negative. And again, they don't give me the b, but they do give me a point that I can use. Write down my fancy sentence here. When x equals -8, y equals -18. Ooh, lots of negatives in this question. And so when I sub in the y there, -18 equals -1/4 times -8. Well, I'm going to put that over 1 right now. I already know what's coming, so I'm going to put that over a 1 because I got to multiply these two fractions together. And then I get -18. Okay, top times top, I get +8. Bottom times bottom, I get 4. And again, like a lot of questions in this chapter, it looks like it's going to be crazy fractions. When you actually multiply it out, you get a nice whole number. Bring that 2 over. And so now I've got my equation. I found the slope, which was -1/4. I found the y-intercept by subbing in -20. So again, great examples in this section because it ties together so much of the stuff that's been done in this chapter already. Okay, next example. Write down y equals mx plus b. Sub in what I know. Okay, perpendicular to this. So this one has slope -1/2. I want the perpendicular slope, so I've got to flip that fraction. So it becomes 2/1. And then I got to change its sign. So it was negative, now it's positive. So I've got a slope of 2 here. Now sub in this point. Now look, again, this is a little bit difficult. This is a point I can use. It's an x-intercept of -12. But what are the coordinates of an x-intercept of -12? And you can draw a little graph to remind yourself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's an x-intercept of -12. That means it has coordinates -12, 0. So my sentence, when x equals -12, y equals 0. 2 times -12 is -24. And bring that over, and I've got my b. Therefore, y equals 2x plus 24. I've got the slope from doing the perpendicular move there, and then I've got the y-intercept by subbing in this very strange point, the x-intercept. Well, it's not that strange, but you do have to do a little bit of thinking there. Now, if you were really caught up and you really understood the 2 lessons before this one, you might have found all those examples pretty straightforward. And I'm going to tell you these last 2 are pretty straightforward as well, but it takes a different kind of thinking because we switch over to these special lines, and these special lines require some special thinking. Okay. I'll draw a little picture here. I want to draw a picture of this line. It says parallel to the line y equals -6. The line y equals -6 is a horizontal line. And if you don't have that in your memory, it's time to get those memorized. Go back to those special lines lesson and make sure you get those special lines very clear in your mind. That horizontal lines look like y equals -6. Because if you don't know that, you're sort of lost in this question because it's hard to know what to do in a question like this if you don't even know what y equals -6 looks like. Having that line on there and reminding me it's horizontal then makes this question a little bit easier because it says it goes through the point -815, and I'm not trying to draw this to scale. I'm trying to say, okay, well, somewhere up here there's this point -815, and they said it was parallel to the line already given. So what I want is a line like, looks something like that. So it comes down to this. The line will have equation y equals some number, some y value. Because if it's going to be parallel to y equals -6, it's got to be another horizontal line, y equals something. What's the something here? It's 15. This thing is going through a y value of 15. So the equation of this parallel line to y equals -6 is y equals 15. That's a very difficult example that becomes easy at some point when you really get what they're saying. What they're saying is find another line that's horizontal. And that horizontal line's got to go through -815. And if it goes through -815, it's got to be y equals 15 because that's the y value that that particular line is going through. One more, sort of like that. This one says perpendicular to x equals 7. Now it's important to know what x equals 7 looks like. X equals 7 is a vertical line going through the value 7. There's what we're talking about here. So if we want to be perpendicular to a vertical line, then we again, in this question, want some kind of horizontal line. And where does that horizontal line go through? It's got to go through the point 1924, up here, way up here somewhere, 1924. I'm not trying to draw it to scale, just trying to get an idea of what's happening. I want a horizontal line going through 19,24. If it's horizontal, I know it's going to have an equation y equals some number. And what's the y value of this point? 24, so it's y equals 24. Boy, I'm not trying to pretend those are easy. Those take a lot of thinking to get through them. But start with this kind of thinking. Start and go, what am I dealing with? Am I dealing with horizontal or vertical? And then once you've decided what you're doing with horizontal or vertical, decide what they're asking for. If they want parallel to that, so a parallel to a horizontal would be horizontal. But if they wanted perpendicular to a horizontal, then they'd want vertical. Then write down what that equation of the line will sort of look like, and then use the points to try and make that decision. Okay, so those take a little bit of practice. I won't say those are easy. Okay, so if you've fallen a little behind, you might have found this lesson a little bit confusing. So it's important to get caught up. Do some of the old homework enough that you get yourself clear on what's happening, and then take a run at this homework. It's not the type of homework, again, that you can just go, oh, I get that, and just move on. You really have to practice them out and really think them out because there's a little bit of thinking involved here. Try that out and have a great day.